Hello, everyone. Good morning, good evening, depends where are you. Uh, Welcome to the webinar hosted by Zenity, Low Code, No Code. I'm Lana. I'm a software engineer at Zenity. I joined Zenity 1.5 years ago. Before Zenity, I worked in Microsoft in the cloud security team. This is my first webinar, so I'm excited. Let's get started. So today we're going to talk about low code, no code. What is low code, no code? Why do we use low code, no code? What are the risks? We're going to talk as well about few of the top 10 security risks and how do we prevent them. And also we're going to bring up some interesting stories from the real world. Please feel free to write down your questions in the chat during the webinar, and we'll try to answer them all when we get to the end. So let's get started. Low code, no code. In simple words, low code, no code is basically building applications and automations without writing the code or with writing minimal a few lines of code. These can be automations, for example, if this then that. So such as if a photo get uploaded to my Instagram, store it into my Dropbox for a backup. Or, for example, it can be business applications such as managing the vendors within the organizations, or applications for the onboarding process for new employees, probably managing their IT equipment, or the offboarding process can be involved as well. These are simple examples of what we can build in these in low code, no code. But definitely we can build much more complicated applications that actually are really critical and stand in the core business of many organizations. So what is the technology behind these platforms? So basically it's drag and drop components that are a wrapper for codes or API or interfaces that connects to another SaaS services or external services, bringing them up all together and consisting building blocks for these applications. So why do we use low code, no code? What is this trend that is spreading fast? The simple answer would be why not? We can build as complicated applications as we can without writing any line of code. So why wouldn't do that? But the real answer is the traditional software development life cycle can take a really long time. It involves multiple steps, as we can see here in this slide. It starts from detecting the problem, the envision, and then planning the solution, creating, verifying, deploying, monitoring, and etc. And with every specific step here, there are multiple stakeholders that are involved, such as product manager, developers, security teams, IT, DevOps, and many more. So this can be very time consuming. From the other side, organizations are growing and moving really fast, and so the need for faster delivery for business applications. Also, low code it simply allows citizen development. It means that anyone without any background in development or with any developer skills can build these applications and automations, and thus accelerate the process of delivery of business applications. So it seems like it's magic, right? We can write as many applications as we want and as complicated applications as we want that answers the business needs and with minimal effort, with few clicks sometimes. So it's a good time to ask, what are these risks? Sorry. So while the traditional software development is optimized basically for quality, for security and maintainability, the low-code, no-code approach is basically optimized for delivery velocity, which is it's making it very hard to keep fundamentals such as security, privacy, and compliance. Also, these fundamentals remains in the hand of the IT to make sure they exist. And sometimes these the processes and tools that the enterprise security is built on do not fit low-code, no-code approach at all. Specifically, processes such as security review and testing, monitoring and detecting threats in the system do not exist at all in low-code, no-code. Also, we can say that, as we see in many situations and in many cases, the IT people or IT department is not even aware that their business teams started low-code, no-code at all. So this leads us to the next slide, which is which we list here the top 10 security risks for low-code, no-code. First of all, this project OS top 10 security risks for low-code, no-code is led by Zenity, and in this project we present what are the top 10 security risks and how do we prevent them. So just like any other type of software, low-code, no-code suffers from design flaws and security vulnerabilities. These varies between privilege escalation, insecure authentication, data leakage, and many more. Today we're going, because the lack of time, we're going to concentrate on two security risks. The first one is data leakage and unexpected consequences, and the second one is security misconfiguration. Maybe we can put on the chat the full link to the project itself, so you can read more about the other security risks and deep dive there. So, data leakage and unexpected consequences. We can see the low-code, no-code automations and applications as data movers. They can move data from point A to B, from external to internal service, from personal account from corporate account to personal account, and the opposite, from SaaS services to on-prem. This data many times often consist of sensitive data, PIIs, and financial information. So if this is done without a caution, this can lead to severe data leakage and unpleasant one. Also, there can be many unexpected consequences, especially when coupling the change in one system or coupling the operation that occurred in one system to a change in another one. And it can also be even worse when coupling the one source of operation of data source with many data movements in other systems, which make it really hard to follow the data flow and fully map the where the data flowed in the different systems. So let's take a look at really simple example to clarify what we're talking about here. So for example, if we take a look, this is a recipe, a simple one that was built by really few clicks, maybe 2 or 3 clicks. So this recipe is about syncing 2 SharePoints. So let's imagine that a maker, business user maker, makes this recipe to sync between the 2 SharePoints. So basically, he subscribed to a change or file upload, as we can see here in SharePoint A. And whenever a new file is detected, then the recipe copies the file into SharePoint B. Another user that is not aware of this automation, by mistake uploads a file that contains sensitive data to SharePoint A. Very quickly, he realized that he did a problem, a mistake, and he deletes the file. In the meanwhile, in the background, what happened is actually the file that contains the sensitive data is synced and stored in SharePoint B. Now, every user that has an access to SharePoint B has also an access to that file. And also, it can consume this file and forward it to probably outside of the organization. So far, so good, or not good. Let's talk now about to look at real example from the real world that combines the email forwarding and data leakage. So business email compromise is a well-known crime. It basically takes advantage of the fact that many of us rely on email to conduct business. So the main attack vector there is basically email forwarding. What happens in these attacks? The attacker takes control over a user in the corporate, a user account, and he starts to build some rules. For example, one of them is forward any message he gets into the inbox to his own personal account. And he does that in order to be exposed to more communication that happens inside the corporate, and hopefully to get some interesting data that he can do anything about it. So he creates these rules, and after that, he also deletes makes a rule that deletes the inbox message, and keeping no space for him to get caught. Many data leak prevention solutions and email vendors trying to solve this by instrumenting the email servers themselves. They're trying to come up with many creative solutions as well. But unfortunately, attackers always find that gap to bypass these rules. And the recent attacks that we're seeing, they're actually leveraging the low-code, no-code platforms for doing that. So if we can, let's take a look at these screenshots. What happens here basically? The attacker takes advantage the low code as a data mover, right? So what he does here, he subscribes to an email to the inbox, and after that, in step 2, what he's doing is actually sending a new email to the personal account, a malicious one, and but the key here is not actually forwarding the email itself, but rather copying the content and the data that was in the original email. And after that, after step 2 is done, he simply deletes the original one. So many low-code, no-code vendors are struggling and trying to come up with creative solutions to protect the platform users. Recently, for example, Microsoft introduced a new header that is being attached to any email that is sent from their low-code, no-code platforms, Power Apps or Power Automate, and basically keeping some space for IT people to protect their email servers. For example, they can create or restrict the inbound or outbound traffic from their email servers, depending on the header attached to the email. But if we take a deeper look here, the Microsoft solution does not really help in this case, because the email servers that are outside of the organization are out of control of the IT department. And also we should emphasize here that the key attack here is actually copying the data and not forwarding the email itself. So any other solution that we should look into, it should take into account 2 aspects or 2 considerations. The first one, it should be in the data layer. It should take a deeper look at the data layer and the sensitivity of the data that is being moved from point A to point B. And the second aspect here, and the also important one, is the identities that are being involved in such an action. For example, here, if we see that we can see that there are 2 identities that are involved: the corporate one and another external identity. So what can we do in order to reduce the attack surface? First of all, it's always a good idea that in our organization, we limit the list of the connectors that we can use to build our applications and automations. Second of all, we should monitor the data flows that goes outside of the organization's boundary, and not only the inbound traffic. Specifically for email forwarding attacks, so it's always good also to, as mentioned here, to be aware of all applications that use the email connectors, and identify the identities that are being involved in that automation. And also, at last, we should identify and address the applications that mix internal identity and external identity. We should be cautious here, because not like mixing identities, internal and external identities, does not really necessarily should be marked as a threat, because organizations sometimes or often do these communications with vendors from outside the organization. But it's always a good idea to be aware of the list of all the automations that do this stuff. Okay, before moving to the next security risk, I see here multiple of questions, but let's try to keep them and answer them to the end until the end of the webinar. Okay, so category of security misconfiguration. Low-code, no-code platforms and vendors support a really rich set of configurations, of application configurations. These configurations can be set on the application layer rather than the tenant layer, which means that every application builder can configure and set the configurations on his or her own application. These configurations often control the balance between security best practices and the business use case itself. We should be careful that misconfigurations can sometimes lead to security breaches, right? Such as exposing unprotected public endpoints or data leakage, or probably sometimes oversharing and many more. Even though vendors are trying to do their best to enforce the security best practices probably and these configurations, at the end, we're human. The application builders are human beings, basically business users that can always do mistakes. So let's see here an interesting case that caused a severe data leakage, and the root cause was a default configuration, a wrong default configuration. So last year, almost 1 year ago, Microsoft announced that there was a huge data leakage from Power Apps portals that leaked about 38 million records that contains sensitive data, PIIs, financial data, and data that should not be public. That data belonged to about 47 authorities, including American Airlines and some governmental bodies. So before let's start to understand. Let's try to understand what happened there. So Microsoft Power Apps is the Microsoft solution, low-code, no-code solution for building business applications, including application capabilities such as user authentication, filling forms, storing data, retrieving data, and so on. The Power Apps portals are basically the websites or the clients that expose these applications to web client users. And also, Microsoft also leverages the OData API. It's an industry standard API to retrieve data. And in the core of Power Apps, they use the Dataverse as a database. It's a SQL managed by Microsoft. So in order to retrieve data from these applications via these portals, we should pull data from lists. These are application configuration, and also to limit. So these lists basically fetch the data from the tables and expose it via the OData API. So in order to restrict actually the access for this list, two things has to be done. Two configurations has to be set. The first one is enabling the table permission on the lists themselves. And the second one, sorry, and the second one is setting the correct permissions on the records in the table themselves. So what happened back then is the Microsoft defaults configuration in Power Apps portals when enabling the OData API was to disable the table permission from the lists. Disabling the permission, the table permission on the list, it ignores any other permission set on the table itself. So basically, everyone, if not changed, who exposed, who built a portal app that exposed OData, all the records were public, were anonymously accessed. So Microsoft's solution for this was obviously changing the default configurations. So the default configuration was set to enable the table permission. And if you wanted to expose public data, the user or the application builder, the portal builder, should go and disable, not disable, even put the right permission, the public permission on the records themselves. So far, so good. The question is, are we 100% protected now? And unfortunately, the answer is no. What I'm going to present here is an interesting case that we discovered into the wild, in the wide internet. Every portal, Power Apps portal that is built is hosted by powerappsportals.com, and any portal that exposes OData, we basically can access this by adding the suffix OData. So by simple enumeration in the internet, we can fetch a fine number of public portals that support OData for many different organizations. So what we see here actually is the OData from a portal for top 50 Fortune company. So we issued HTTP request, and then we get this file that says that the OData tables that are being exposed from the specific portal are the first one is the default, interesting but not enough. The second one is entity form set. Could be interesting, but the more interesting one is the global variables. So we ask ourselves, what are these global variables and what can be stored there? So by adding the suffix OData and global variables, what we got the data from the global variables table. And unfortunately for this company, what we found is part of the data that was stored there contained, as we can see here, documents API authentication. And we found the bearer token for, as written here, the OAuth token to access Azure API. And this is really bad and unpleasant to happen. So this was done by configuring the wrong permissions on the records on the table itself, even though the Microsoft solved the problem of the default configuration on the list on the list level. So this is an example for when we can misconfigure our application and what it can cause. So what we can do to reduce the attack surface here? Probably some of the points would seem as very obvious to some of us, but but for example, like for the first point, read vendor documentation and follow the best practices. This is really obvious to do, right? But even though Microsoft emphasized in its documentation that misconfiguring the table access could leak data, it seems like it wasn't emphasized enough, and users did some mistakes, severe ones. We should always ensure that configurations align with the industry best practices. And also, it's very recommended to change the management system for the tenant level configuration rather than the application configuration. So all the security configurations best practices would be enforced in the at the tenant level and not the application level itself. So I think we reached to our end, unfortunately, and we're running out of time. So first of all, I want to thank you all for coming and listening to my first webinar. I hope it was interesting enough. We will try to address all of your questions. I see plenty of questions in the chat. We'll try to reach out to you later by email. Thank you for joining. Goodbye.